All right, you guys, we're finally into unit lesson 3-3. Unit 3 is all about trig. So what we're going to do now, though, is we're going to shift gears and look at angular velocity and linear velocity. So question 7 is pretty straightforward, actually. They give us in 7 part A, they give us more information than we need. We use half of that in part B. So when it says you have a bike whose wheel radius is 15 inches, that is going to be helpful when we start looking at finding linear velocities. So linear speeds would be like miles per hour or feet per second. But angular speeds, those are either like revolutions per minute or radians per minute. And just to recap, in the unit circle, in order to start at 0 and go all the way around the circle, that's 2 pi radians. So that's going to come in handy here in a minute. So question 1, messenger rides a bike. Wheels are 15 inches. Part A, the tire is rotating at 140 revolutions per minute. They want us to find the angular velocity in radians per minute. So all of these you start by writing them out in fraction form. Units are the most important thing. So I would write revolutions per minute like that, revolutions per 1 minute. Now we need to multiply that by some fraction. We get our desired units in the end. Our desired units, they're asking for radians per minute. In fact, it's per 1 minute. So in order to get that, we already have minutes. We end with minutes. So we're not going to do anything with minutes. What we do need to get is from revolutions to radians. So in fraction form, when we take one fraction here times another fraction here, we need revolutions to be the units in the bottom. And what that's going to allow us to do is say that the revolutions units kind of cancel, so to speak. On top of that, we also need radians to be the unit that we introduce, because in the end, we want radians because we end with radians. So looking at that, though, radians per revolution, well, that's where this comment came in from previously. What I'm getting at is 1 revolution is all the way around the circle, and that's 2 pi radians. All right, so that's just tried and true. If they want you to go from RPMs, revolutions per minute, to radians per minute, all you do is take the number they give you times 2 pi. So this one, in this case, is 280 pi. So your final answer is 280 pi rad per minute. Now, one thing to note, I am leaving the pi symbol in there, and that is a perfectly acceptable answer when you're talking angular velocities. Later on, we're going to have to, like in part B here, we don't want to leave pi in there, and I'll explain that later. But for this one, it is perfectly fine. Leave 280 pi radians per minute. So that's question 7. Make sure I got that right. If you were to run that out, it would be something about 879.7 radian per minute. So if you wanted to know what that would be, it'd take you 180 times about 3. So 300 times about 3 is about 900. There you go, 879. All right, B. B, we are going to take the information and go a little bit further, except this time you're learning that you are not at 140 revolutions per minute, you are 2.5 revolutions per second. So I don't know, that's an interesting combination, looking at revolutions per minute. But we're going to try to go from 2.5 revolutions in 1 second. So take your hand if you want to try and gauge what that looks like, and go around, make a circle with your hand, count to 1, and see if you can get 2.5 revolutions in that 1 second. So that's about how fast you're traveling. It's asking you to find the linear speed. So find the linear speed in miles per hour. So this one's no different than A, except we just have more fractions to do. So we have 2.5 to start with. That was rev per, oh no, sorry, I almost said per minute. That would be very slow. So in that case, what I was saying, I know I'm going to have a lot of fractions. In fact, I'm going to start with just 3. In the end, and maybe I better leave room for 2 of them. In the end, I need miles per hour. So if you look at the units that we start with, revolutions, and we need to end with miles. We have seconds, we need to end with hours. So some people find it easiest to do this as let's get rid of time conversions first. When we do that, there's 2 ways. You know, if you wanted to go from seconds to hours, one way to do it, and I won't put numbers and leave them, but I need to get rid of the seconds unit here. So we have seconds. The first conversion we think of is turning that into minutes, right? So that would be like 1 minute is 60 seconds. That gives us that seconds cancellation. Now, we have minutes, so we're revolutions per minute, but we still want hours. So we need to get rid of minutes now. We've got to minutes, but just temporarily to get to hours. So 1 hour is 60 minutes. So, but you see how we've got 2 fractions consumed. So we can do that, that's fine. But the other way to do this, I'm going to shorten this up, eliminate a fraction. What you can do is say, well, maybe I'm just going to figure out real quickly that that's 3,600 seconds in 1 hour. So if you take 60 minutes, 60 seconds, you double it, or you multiply it, you get 3,600. So that just saves you a fraction. It's up to you how you want to do that. But the key is we've got revolutions per hour. So now we've got our hours unit. Now we need to get revolutions to miles. The first conversion we need to do is get rid of revolutions. So 1 revolution, we don't care about radians right now. What we do care about is linear distances. So if you think about it, what is 1 revolution of a circle? It's also known as what? It's known as the circumference of the circle. So I'm going to use the equation to say that 1 revolution is really 2 times pi times the radius. That's where that number comes in handy from here. It says the wheel has a radius of 15 inches. So now we have inches. Revolutions are canceling. We have inches per hour. We need miles per hour. We're getting there, you guys. We need to get rid of inches units. So the best, most obvious, because I don't know how many inches are in a mile, but I know that there are 12 inches in a foot. And I also know that there are 5,280 feet in a mile. So if I cancel those units, and I've canceled those units, I am left with miles on top, hours on bottom, and a lot of math to do. Now, there's 2 approaches. The one approach would be, all these are our fractions multiplied together. So if I take a fraction times a fraction, the way you do that is take the top numbers and multiply them together, take the bottom numbers, multiply together, and then you can see if you can reduce top divided by bottom. So in that respect, we take 2.5 times 3,600 times 2 times pi times 15, and then times 1, but that doesn't change it. So we would get a number on the top by doing all of that. You do the same thing in the bottom, 1 times 1 times 1, 12 times 5,280. So you would get a big number on the top, another number on the bottom, and then your final answer would reduce. So if we do that, let's do that quick. 2.5, 3,600, clear that. 2.5, 3,600 times 2 pi radius. And was that all of it? Yes. Oh, geez. There. So it's a really big number. I'm not even going to have room to write that on my page. So, but let's save that, right? So I would put that 8,000 something of their number. No, 848,000. 848,000 miles per how many hours? Well, 12 times 5,280. Per 63,360. So what you have to do is then take those two numbers, divide them. So I'm going to go up here. I'm going to say big number divided by that number. You get 13.39. Which is your final answer. The other way to have done this is to just straight through 2.5 times 3600 times 2 times pi times 15. And then simply at that point say divided by 1, divided by 1, divided by 1, divided by 12, divided by 5,280. So what that looks like is 2 times 3600 times 2 pi r. Right, let me make sure I'm doing this right. 2.5 times 3600, 2 pi, okay. Nope, that's 2.5 times 3600 times 2 pi r. Answer. Now, at that point, you can then, rather than take 12 times 5,280 and then getting two different numbers, you can say divide by 12, get an answer. Divide by 5,280, get an answer. You're still at 13.39. So you could do it that way. There's lots of ways to do it, but your goal is to get that fraction reduced. So there you have it. You have questions 7, A and B, and we will get to 8 in the next video.